Now, our next notion is to ramp this notion of determinants up into a 3 by 3 system. So the structure should be straightforward. 1, 4, 0, negative 1, 0, 2, 1, 1, negative 1. I'm just picking numbers out of the blue sky, but a 3 by 3 determinant. A determinant must be a square system. You know, not allowed to have 2 rows, 3 columns, or something like that. It must be square, so the number of rows must match the number of columns. And so this is a 3 by 3 determinant. Remember, a determinant will equal a number. It is a specific number. Now, there are several ways to go about doing this. What we're going to do is what's called expand across minors. Expand across minors. So that's just the language that's used. We inherit that from linear algebra. What this means is this. You are free to choose any row or any column, of this determinant. And so let's choose. Suppose we choose the top row. The top row. So I'm going to expand across the top row. All right. So here's the procedure. The minor of 1, the minor of the row 1, column 1 position is this. You eliminate the row and you eliminate that column, and you're left with a smaller 2 by 2 determinant. So the minor of 1 is you eliminate the row, you eliminate the column, and that generates this smaller determinant, 0, 2, 1, negative 1. The minor of 4 is you eliminate the row and that column, and you're left with a 2 by 2, negative 1, 2, 1, negative 1. And then the minor of 0 is eliminate that row, eliminate that column, and you're left with a small 2 by 2. So every position, now you're free to do this now, so it'll be harder to see here. Suppose we expand across the third column, right? So you eliminate the third column. The minor of 0 is eliminate that column, eliminate that row, here. And there's that minor. The minor of 2 is you eliminate this column and you eliminate that row. You're left with the 1, 4, 1, 1. The minor of negative 1 is you eliminate that column, eliminate that row, and you're left with 1, 4, negative 1, 0. So every position in the determinant has a minor. You are free to choose any column, any row you want. It turns out, it is not obvious, it turns out that the computation, even though the individual values are different, the ultimate value of the determinant is always the same. So I'm going to expand across the top row. And so here's the procedure. 1, and then you multiply it by the minor of that. So you take 1 and multiply by the minor. That is the determinant 0, 2, 1, negative 1. And we'll come back and compute that in a bit. Now I need the minor of 4. So eliminate that row, eliminate that column. So that's 4. And when you eliminate that column, that is negative 1, 2, 1, negative 1. And then finally, the minor of 0, eliminate that row, eliminate that column, negative 1, 0, 1, 1. And now, there's another little detail we need to work out. Where this comes from is something in linear algebra. There's the system of signs. It's a checkerboard arrangement of positives and negatives. Positive, negative, positive, negative, positive, negative, positive, negative, positive. The sign of each of these expressions is determined by this grid. So the minor of 1 is positive, so this is positive 1 times that determinant. But the minor of 4 is negative. So when you do this computation, this needs to be subtract. And then you do the minor of 0, that needs to be addition. So this is positive, this is negative, this is positive, because those are the signs of this checkerboard arrangement for the top row. Where this comes from is some deep theory in linear algebra. For our purposes, we don't need to worry about that. This is given. And so, if we were to expand across, let's say, the middle row, then the sigma would be negative, then positive, then negative. It turns out, for our purposes this semester, we are always going to be expanding across the top row, and so it will always be positive, negative, positive. The rest of this is straightforward computation. This is 1 times, and you do the determinant here the same way we did the 2 by 2s. Multiply, subtract, multiply. Well, multiply 0 times negative 1 is 0, minus multiply 2 times 1 is 2. Multiply, minus, multiply. This is always subtraction when you do the 2 by 2 determinant. Now be careful with the signs. Multiply negative 1 times negative 1 is positive 1, minus multiply 2 times 1 is 2. And then this is 0, so it really doesn't matter what happens here, but this is negative 1 minus 0. It's going to be times 0, so it doesn't matter. This is now 1 times negative 2, minus 4 times negative 1. Be careful with the signs. Plus 0. That's negative 2 plus 4 plus 0 is 2. Now, it is not obvious, but you could expand on any column, any row. No matter how you do this determinant, you always get the value of 2. The individual values will be different, intermediate values, but the final result is always going to be the same. All right? So what's next to do is to just practice this a couple times, and that's what we'll do next.